Welcome to the Western Regional Laboratory of the Bureau of Indian Standards. In the light of growing emphasis on the quality and safety in the Indian manufacturer industry, there is a critical need for comprehensive resources that elucidate the process of product testing according to Indian standards in the form of videos on the testing of products. The purpose of this video from BIS is to facilitate industrial professionals, to educate consumers, to aid educational institutes, and to support stakeholders.
BIS has established a network of state-of-the-art laboratories across the country, and Western Regional Lab Mumbai is one of them. At BIS Labs, we carry out testing of various products as per the test methods given in Indian standards, thereby ensuring that only products with the right quality reach the Indian consumers. भारत देश को एक गुणवत्ता सचेत राष्ट्र बनाने के लिए हमारी प्रयोगशालाएं हमेशा तत्पर हैं.
In this video, we are going to demonstrate the various tests performed on high-density polyethylene HDPE pipes used in water supply systems by Indian standards.
High-density polyethylene pipes are widely used for water supply due to their flexibility, durability, and resistance to corrosion. To ensure safety and performance, the Bureau of Indian Standards has set IS 4984, which specifies the requirements and testing procedures for HDPE pipes. Testing as per IS 4984 ensures that the pipes meet safety and quality standards before reaching consumers. It evaluates key parameters such as strength, pressure resistance, and material composition. One critical test outlined in the standard is resistance to internal hydraulic pressure test, which ensures that the pipes can withstand sustained water pressure without bursting or deforming. Without such testing, substandard pipes could lead to system failures, water loss, or health risks due to contamination. Additionally, poor quality pipes may deteriorate faster, causing frequent maintenance issues and higher replacement costs. Meeting BIS standards guarantees product reliability, enhances consumer confidence, and ensures safe and long-lasting water distribution systems.
The Bureau of Indian Standards has developed Standard IS 4984-2016, outlining the quality parameters essential for HDPE pipes. The standard classifies pipes based on their pressure ratings as follows. Further, the standard categorizes pipes into different types based on their applications. First is PE63, which is used for low pressure applications. Second is PE80, which is used for medium pressure applications. Third is PE100, which is used for high pressure applications. Additionally, the standard specifies different standard dimension ratios SDR for HDPE pipes, which define the ratio of the outer diameter to wall thickness. Now, let's see how HDPE pipes are tested as per the Indian standard. Pipes are visually inspected for surface quality. The internal and external surfaces must be smooth, clean, and free from grooving or defects. Standard HDPE pipes are typically black, but they can be manufactured in other colors based on mutual agreement between buyer and seller.
The next test is density test. Density testing of HDPE pipes as per IS 4984 ensures material consistency, identifies contamination or improper polymer composition, verifies mechanical properties, and ensure long-term durability and performance.
The test apparatus includes an analytical balance capable of measuring to 0.1 mg precision. A test specimen of 4 cm square piece is cut out. The specimen is first weighed in air, then submerged in butyl acetate at 27 ± 2 degrees Celsius and weighed again. The density must be between 940 and 960 kg per meter cube.
Next test is dimension test. Ensuring quality in HDPE pipes begins with checking various dimensions of the pipes. The outer diameter is measured using instruments like a vernier caliper and pi tape. Wall thickness is measured with a dial vernier or ball-ended micrometer.
These measurements are compared against the specific tolerance limits to ensure compliance with the standard. Accurate dimensions are crucial for proper fitment, pressure handling, and overall performance in water supply system.
The next test is melt flow rate test. The melt flow rate test evaluates the flow properties of HDPE material under heat and pressure, ensuring consistency in material quality.
For this test, a composite sample from a minimum of 3 pipes is used. The test is performed at 190 degrees Celsius with a nominal load of 5 kgf. The sample is placed in the MFR testing apparatus where molten polymer flows through a standardized die under a specified load. The weight of extruded material over a set of time is measured. The MFR value obtained must not deviate from the MFR of the resin, ensuring consistency in material properties and processing behavior.
The next test is the tensile test. This evaluates the mechanical strength of HDPE pipes, ensuring they can withstand axial forces without breaking.
The test is conducted using a tensile testing machine with a controlled speed of separation as per the standard. The test specimen is cut or machined from pipe lengths in the longitudinal direction following standard dimensions. Before testing, specimens are conditioned at 27 ±2 degrees Celsius. The specimen is mounted on the machine and load is applied until fracture. The tensile strength is calculated by dividing the load at fracture by the original cross-sectional area. The test is conducted on specimens and the average tensile strength is taken. The required yield strength and elongation at break should not be less than 15 megapascal and 350% respectively.
The next test is the reversion test. The reversion test evaluates the thermal stability of HDPE pipes by examining their dimensional changes when subjected to heat. This test ensures that pipes maintain their integrity under high temperature conditions.
For the test specimen of pipe approximately 200 mm long is cut. Then 2 circumferential marks at 100 mm apart are scribed on the specimen. For this test, concave side up specimen is placed on a glass plate. Specimens are heated in an oven at 110 ±2 degrees Celsius with continuous forced air circulation and then allowed to cool to room temperature. After cooling, the distance between the 2 scribed marks is measured and percentage change in length is also measured. The length shall not alter by more than 3%.
The next test is the carbon black dispersion test, which evaluates the uniform distribution of carbon black within HDPE pipes. Proper dispersion ensures UV resistance and enhances the durability of the material.
For this test, a microscope with a magnification of at least 200 ±10 is used to examine the dispersion of carbon black particles within the HDPE material. A thin section of the HDPE pipe is carefully cut and prepared for microscopic examination. The sample should be free from surface defects or contamination. The prepared specimen is placed under the microscope and examined for carbon black particle distribution. The test evaluates whether the carbon particles are evenly distributed throughout the material. The dispersion must be uniform with no visible agglomerates or clusters. This test ensures that HDPE pipes have proper UV resistance and long-term durability, making them suitable for outdoor and high exposure applications.
The oxidation induction time test is done to evaluate the thermal stability of HDPE pipes to ensure that they are resistant to oxidative degradation.
Differential thermal analyzer (DTA) is used, calibrated with pure indium and tin for accuracy. The test is performed after 200 degrees Celsius under nitrogen followed by oxygen exposure. A core sample is extracted from the pipe, cut into 15 plus minus 0.5 mg discs from the inner, outer and mid-wall sections. The specimen is placed in an aluminium pan inside the DSC. For 5 minutes, under nitrogen, oxygen is introduced and the oxidation exotherm is recorded. A sample passes if its OIT meets the minimum requirement in IS 4984-2016. Lower values indicate reduced thermostability. In conclusion, the test specified in IS 4984 for high-density polyethylene HDPE pipes are crucial to guarantee the safety, durability and performance of these pipes for water supply applications. These tests ensure compliance with quality standards by accessing These tests ensure compliance with quality standards by accessing aspects like material composition, resistance to internal pressure, long-term strength, flexibility, and environmental durability, confirming their reliability for diverse conditions. Thank you for watching this educational series on product testing as per Indian standards. For more detailed information, please visit our official website at www.bis.gov.in. To stay updated with the latest news and developments, follow us on our official social media platforms.